What if the sun, billions of miles away, is subtly changing the ground beneath your feet? We often focus on solar flares hitting our atmosphere, but what about Earth's molten core? Prepare to uncover the astonishing, often ignored connection between distant solar storms and the very heart of our planet. Hey, friend, imagine this. You're sipping your morning coffee, scrolling through news about the latest aurora light show caused by a solar storm, and you think, cool, but that's just up in the sky, right? Wrong. Or at least, that's what we're starting to question. We've all heard how these massive bursts from the sun can knock out satellites, fry power grids, or paint the night with those ethereal northern lights. But what if I told you the story doesn't stop at the surface? What if these cosmic tantrums are whispering, or maybe shouting, down into the depths of our planet, tweaking things in ways we barely understand? Buckle up, because we're diving into the wild world where space weather meets Earth's hidden underbelly. It's not just sci-fi, it's science that's bubbling up, and it's fascinating as hell. Let's start by busting that common myth head-on. Most folks, including a lot of experts until recently, figured solar storms were all about the outer layers, zapping our tech, stirring up the atmosphere, and maybe giving pilots a headache with radio blackouts. Picture Earth like an onion, layers upon layers, from the crust we walk on, down through the mantle to the outer core, a seething ocean of liquid metal, and the solid inner core. The magnetosphere, that invisible force field generated by the churning in the outer core, is our first line of defense against solar onslaughts. When a solar storm hits, it doesn't just bounce off, it interacts, twisting and stretching those magnetic field lines. This can create electric currents that flow through the atmosphere and, crucially, induce secondary currents in the conductive parts of Earth's interior. Think of it like dropping a stone in a pond. The ripples spread out, but some energy sinks deeper. Research shows that geomagnetic disturbances from solar activity can penetrate the surface, inducing electromagnetic fields that affect the Earth's conductivity from the crust to the mantle. Take geomagnetic solar flare effects, or crochets, as they're sometimes called. These are sudden spikes in the magnetic field observed during flares. Studies dating back to the 1950s, like work by Tsutomu Rikitake, revealed something intriguing. About 1/3 of the geomagnetic changes we measure on land actually originate from inside the Earth, not just the ionosphere. It's like the planet's interior is responding, echoing back through electromagnetic induction. When the sun flares up, it boosts the ionosphere's conductivity, and that sudden change induces currents that flow downward. Later research confirmed this ratio holds for various geomagnetic variations, including those from solar storms. We're talking about energy being transferred, albeit indirectly, into the Earth's conductive layers. Is it enough to shift things? Not dramatically, but over time, who knows? It's like a subtle vibration that might accumulate. Now, let's get to the juicier, more controversial bit. Could these solar shenanigans actually trigger stuff like earthquakes? I know, it sounds out there, like something from a disaster movie. But hang with me. There's data pointing in that direction, even if it's hotly debated. The U.S. Geological Survey flat out says no. Solar flares don't cause quakes because those are driven by tectonic forces deep in the interior, independent of space weather. Fair point. Earth's plates grind away regardless of what's happening on the sun. But other researchers argue there's a correlation, especially in seismically active zones where faults are already primed to slip. For example, look at some case studies from the early 2000s. A massive sunspot in 2003 unleashed a geomagnetic storm, and just days later, a 6.8 magnitude quake hit off Japan's coast. Coincidence? Maybe, but the timing lines up with spikes in planetary magnetic indices, like KP, and electron flux from the CME. And it's not just earthquakes. Some studies link cosmic ray variations, modulated by solar activity, to broader Sun-Earth connections that might influence the lithosphere. When solar wind particles barrage the magnetosphere during a storm, They can enhance ionospheric currents, which induce geomagnetic perturbations that penetrate deeper. In active fault areas, this might act as a trigger. Critics say correlations aren't causation, and with millions of variables, it's hard to prove. But proponents point to patterns. Sudden rises in Kp values and particle fluxes often precede quakes by hours or days in vulnerable spots. It's like the sun's poking at Earth's weak points, and if the timing's right, boom, seismic release. But let's push even deeper, to the core itself. This is where things get really speculative, but exciting. Earth's magnetic field is born in the outer core, where convection of molten iron creates a dynamo effect. Solar storms batter the magnetosphere, but could they seep energy all the way down there? One way to think about it is through the Lorentz force, the interaction between moving charged particles and magnetic fields. Solar wind protons slamming into our field could theoretically transfer a sliver of kinetic energy inward. Rough calculations suggest it's tiny, around 320 kilowatts of net energy pumped into the geomagnetic field, with maybe half exciting particles and the rest potentially heating the outer core ever so slightly. Over billions of years. Could this add up? We're talking geological timescales here. The core's heat drives the dynamo, and any external nudge might influence field reversals or intensity fluctuations. Skeptics argue it's negligible compared to Earth's internal heat from radioactive decay and leftover formation energy. The sun dumps about 160,000 terawatts on us via radiation, but most bounces off or gets re-radiated. Still, during intense storms, the interaction isn't zero. The magnetosphere absorbs and redistributes energy, and some models suggest long-term solar cycles could correlate with geomagnetic excursions, times when the field weakens or flips. For instance, periods of high solar activity might subtly modulate the core's convection patterns through induced torques or heating. Don't get me wrong, this isn't settled science. Mainstream views, like from NASA and NOAA, emphasize solar storms' threats to tech and space assets, not the planet's guts. But emerging papers and discussions are challenging that. Why? Because we're getting better data. Satellites like SWARM and GOES track magnetic perturbations in real time, revealing how storm-induced currents flow through the mantle. And with solar cycle 25 ramping up, peaking around now in 2025, we're seeing more events to study. Recent storms have sparked auroras farther south than usual, hinting at stronger interactions. So, what does this mean for us? Practically, if solar storms do tweak the interior, it could refine earthquake forecasting. Imagine monitoring space weather as a quake precursor in hot zones, rising electron flux as a red flag. On a grander scale, it reframes our planet as part of a cosmic web where the sun's mood swings echo through rock and metal. It's humbling, right? We're not isolated. The ground under your feet might quiver to a solar rhythm. Look, I'm no alarmist. This isn't about doomsday. The effects are subtle, often drowned out by Earth's own dynamics. But ignoring them? That's the real misconception. Scientists are digging deeper, literally and figuratively, because understanding these links could safeguard our future. Next time you see those auroras, remember, it's not just a light show. It might be the sun chatting with the core, billions of miles away, but closer than we think. What do you say? Ready to keep an eye on the skies and the depths?